Good afternoon, class. In this section, we will be looking at question 8, 11 and question 12 of your exercise 7D. Okay, of your exercise 7D. Alright, I'll be going through these three questions. Let us take a look at question 8 first. The figure shows the cross-section of a roof ABPC of an old cottage. It is given that AP is 5 meters, PC is 8 meters, angle APC is 60 degrees, and angle ABC is 45 degrees. Find the length of AB. Now, I just want to take note that if this is 60 degrees, this will be 120 degrees because this is adjacent angles on straight line. So, if I want to find AB, I will just have to use the sine rule here, whereby this is the opposite and this is the opposite. I'll have AB over sine 120 is equals to 5 over sine 45. I bring this over, I can find AB as 6.12 meters. Okay, next part, we are going to find the length of AC. Now, we are going to look at this triangle. I know these two sides and the included angle. I can use cosine rule to find AC. So I'm applying cosine rule over here, then I take the square root. I'll be able to find AC as 7 meters. So I'm able to find AC as 7 meters. Okay, now I'm moving on to question 11. Now question 11 says that the figure shows a quadrilateral with the dimension shown. Find the value of A and find the value of A and theta. Alright, now let us take a look at the diagram. Alright, now if I want to find A, I will have to look at this triangle. This is opposite 60 and these two sides, this is the included angle or the sandwich angle. So we apply cosine rule here. We can find A as 5.57 when we apply the cosine rule. Now, we already know the side A, and this is 5.5677. If we want to find theta, we will have to look at this other triangle, the red one, and note that theta is opposite 5.677. I can use the cosine rule as well. So, I'm going to apply the cosine rule here, then I'm going to shift this over this side. 5 square plus 7 square, I move this over, become minus. Okay, then I'm going to carry on from here. I leave the cosine theta here. I move everything over, I'll get this answer. And in order to find the angle theta, I will have to press cosine -1 in order to get the angle. So the angle will be given to 1 decimal place for the final answer. So the value of A is 5.57 and the theta is 52.1 degrees. Alright, so this will give you the solution to question 11. Okay, this will give you the solution to question 11. Now, we are moving on to question number 12. Okay, we'll be moving on to question number 12. Okay, let us take a look at the question. In the figure, D is a point on CB such that AD is 2 cm, AC is 4.5 cm, and CD is 3.5 cm, and angle ABD is 50 degrees. Find angle ADB. So ADB, I'm supposed to find this angle. Okay, let me just shade it again in green. I am supposed to find this angle. Now, if I'm able to find this angle theta, I will take 180 degrees minus theta. I will get the required angle. So let's take a look at this triangle. Theta is opposite 4.5, 3.5 and 2 are the sandwiching this particular angle theta. So I can use cosine rule. 4.5 squared is so and so forth. I apply. I shift it in the appropriate manner. Cosine theta, I will get -2/7 When I press the calculator, I will get 106.601. Now, this is not the final answer because they are asking for the other angle that is over the other side. So I will have to take 180 degrees minus 106.601 because it's adjacent angles on a straight line. I will get 73.4 degrees. So angle ADB is 73.4 degrees. Okay? Now next part, they say the shortest distance from A to CB. Now let me just tell you that the shortest distance from a point to a line will always be the perpendicular distance. Okay, so this is the height H. Okay, now this angle just now I found it to be 73.399. So it's this angle here. This is the side H, and this side we already know that is 2. I'm going to draw this triangle over here. So this is 2. This angle is 73.399. This is H. I will use sine in order to find H. So I do the necessary manipulation, and I will get your H as 1.92 cm. 1.92 cm. And that will complete our part 2 of the question. Okay, now we are moving on to the last part of the question. They want us to find the length of BD. Now I just need you to look at this particular triangle here, ADB. This triangle that I'm shading here. I need you to look at this triangle. Now I know this is 73.399. I know this is 50. I'll be able to get this angle because this is angle sum of triangle. This angle will be 56.601. Note that this is opposite this and this is opposite this. I'll be able to apply sine rule. So BD over sine 56.601 equals to 2 over sine 50 degrees. So BD will be 2 over sine 50 degrees times sine 56.601. When I key the calculator and I round off to 3 significant figure, it will be 2.18 cm. It will be 2.18 cm as the final answer. Now I realize that in your working or in your presentation of your work, many of you do not write degrees. Now it is important that you write degrees because we are measuring angles in the degree mode in all this section. Because angles can also be measured in another unit. Okay, so it is necessary for you to write degrees. Do not leave out the degrees because it is not correct and marks will be deducted. Okay, so this will be the solutions for exercise 7D, question 8 to question 12. Okay, thank you class.